Good morning. So today we will discuss about El Nino and La Nina. So these are the two major oceanic currents, and these currents are mainly observed. Actually, these are in true sense these are not currents. Rather, it's a condition in which the ocean and atmospheric conditions are changed over the Pacific Ocean. Now, the change was first documented by Darwin and his co-workers in the middle and late half of the 19th century when they start roaming the surrounding islands of the Eastern Pacific. Now, Darwin noted that in the Eastern Pacific, in different years, he found that there is some atmospheric instability. That is the uh, pressure, atmospheric pressure, which changes in different years. The pressure system is not remain same in year after year. So he noticed an atmospheric instability, but it was found in many stories and many ancient literatures. But that before Darwin, uh, many fishermen they also found some kinds of difference in the uh, temperature condition of the Eastern Pacific Ocean. That is the change in sea surface temperature in the atmosphere, in the surfacial condition of the ocean. And depending on this change in sea surface temperature in different air and different years, the productivity of Eastern Pacific also change from year to different year. That is the uh, amount of fish they can capture, that also varies. Now, presently, scientists thought that the atmospheric instability, which is observed and noted by Darwin, uh, and he named it as Southern Oscillation, and the unusual temperature difference in the sea surface in the Eastern Pacific, particularly in the coastal areas of Peru, Ecuador, in those areas. These two things are not isolated, they are mutually related to each other. So, the two phases or two unusual conditions observed in the Eastern Pacific. One is the warm conditions, and one is the cool phase than the normal condition. So all these things are observed in the equatorial Eastern Pacific. And due to this unusualness of unusual warm and unusual coolness of the sea surface temperature, the productivity, the biotic activity in this Eastern Pacific also changes. And these two phases or these two conditions, which is uh, not normal, these two are known as El Nino, that is the warm phase, and the cool phase is known as La Nina. And together, these El Nino and La Nina are formed a larger uh, thing which is known as El Nino Southern Oscillation. Now, this El Nino Southern Oscillation can be abbreviated as ENSO. So basically what I told previously, that Southern Oscillation is the change in atmospheric condition, that is the atmospheric instability as documented by Darwin in the Eastern Pacific, and El Nino is the change in uh, sea surface temperature, that is the sea surface temperature being warm. So two events mainly observed by the scientists and common peoples. One is the relatively warm phase than the normal, that is known as El Nino, and the second is the atmospheric instability, and that is observed by Darwin and his co-workers, that is known as Southern Oscillation. And these two things are mutually related with each other, and together they are known as El Nino Southern Oscillation, or in short ENSO. Now, these deviations from normal sea surface temperature can have a large impact not only to the oceanic processes, oceanic surface temperature, to the local biological activity, but it also have an impact on the global climatic conditions. Now, in few uh, times within a decade time span, that is within 10 years, sometimes it happens once, or sometimes it happens 3 to 4 times, or sometimes even more. What I mean, that there is no periodicity of occurring of El Nino and La Nina. Generally, it is thought that the events occur about every 2 to 7 years, but there are records in which El Nino and La Nina are occurring more frequently. Now, related and changed with the ENSO timings and with the ENSO occurring in different years. Generally, ENSO is found to occur at the end of the year during the month of December, and typically it is found to occur or found to last 9 to 12 months. But in the history, it was found that some prolonged events are also found to occur which last for more than a year. Now, what happened in ENSO? So, if we look at the different states of ENSO, we can broadly divide ENSO into uh, three states. So one is the normal condition in which there is no warming or cooling in the Eastern Pacific. Second is the warm phase, that is known to us as El Nino, and depending on this warm phase in the sea surface temperature, the atmospheric pressure is also changed, ocean circulation is also affected, and the biological activity, particularly in the western coasts of North and South America. And keep it in mind that this ENSO is particularly observed in the equatorial Eastern Pacific. So three state, first is the normal state, second is the warm phase or El Nino, and the third one, that is the cool phase or La Nina. Now, before going to know what happened in El Nino, that is the warm phase, and what happened in La Nina, uh, first we have to understand what happens during normal conditions in the entire Pacific Ocean along the equatorial region. So here you can see this is the equator, that is the 0 degree latitude. Now on two sides of equator, the trade winds that is generally blowing from northeast to southwest in the northern hemisphere and from southeast to northwest in the southern hemisphere. Here you can see these white arrows in the bottom picture, which is showing during normal time the trade winds which we already learned in our previous classes when we came to know about the global atmospheric circulation. So along the equator in the Pacific Ocean, the trade winds are blowing overall from east to west. Now, due to this trade wind, a gathering of the hot, warm water in the equatorial region that is pushed towards the western Pacific. So trade winds are blowing from east to west, and the warm water found in the equatorial region that are moving as equatorial current towards the western Pacific. So all the western Pacific areas, western margin of the Pacific Ocean, there we found an accumulation of a large amount of hot water. So due to the accumulation of hot warm water in the western Pacific, a lot of evaporation takes place in the western margin of the Pacific Ocean, and due to the evaporation a lot of cloud formation occurs and it causes a lot of precipitation, lot of rainfall in the um, eastern margins of continents like Australia, Papua New Guinea, Indonesia, Japan. So all the eastern part of these land masses, they evidence a warm, humid climate as well as a huge precipitation, a huge amount of rainfall. Now, with continued rainfall, when these clouds goes up, becomes cooler and relatively drier with continued precipitation, so they move towards the uh, eastern Pacific, and when reaching the eastern margin of the Pacific Ocean, that is on the western part of the American landmass, they becomes heavy, they becomes denser, and they come to the earth surface, and here forms a high pressure zone. So at the eastern Pacific forms the high pressure zone, and at the western Pacific there forms a low pressure zone. So if you look at the atmospheric pressure condition, two different types of pressure condition exist which governs the atmospheric circulation from eastern Pacific to western Pacific in a circular cell, and due to this a lot of rainfall is found to occur in the western Pacific. In contrast, the eastern Pacific, which is a high pressure zone, there the atmospheric condition is relatively stable with a dry, uh, cold condition. Now, with continuation with this atmospheric circulation, it is first observed in the year of 1920 by a British meteorologist called, his name was Gilbert Walker, and he found that along with this atmospheric circulation which occurs due to change in atmospheric pressure conditions, the seas or the ocean water in the Pacific, that also circulates in a circular pattern. So as the trade winds blow the hot warm water towards the western Pacific as surface current in the form of equatorial current, now the eastern Pacific becomes void. So the cold bottom water that takes the place in the eastern Pacific, that goes up, that means upwelling occur in the eastern Pacific, and when there is a crowding or there is a gathering of warm ocean surface water in the western Pacific, there forms a mound of ocean water. So that is the place of convergence of warm water. So due to this convergence, here a downwelling occur. So you can see that along with the atmospheric circulation which occurs in a clockwise fashion, the water of Pacific Ocean that also encircles with depth in a anti-clockwise fashion. Along the surface, the warm water moves by the trade winds from eastern Pacific to western Pacific. Then there is a mounding or heap of warm water forms, becomes the zone of converging, and due to this downwelling occurs, and at the eastern margin of the Pacific Ocean, the cold bottom water reach the surface in the form of upwelling. Now due to this upwelling, as we already know, upwelling brings a lot of nutrients along with it. So as there is a lot of nutrient supply, fresh nutrient supply, so the eastern Pacific becomes a favorable spot for biological activity. Lots of different types of um, organisms, marine organisms, are found in the eastern Pacific, and that will also enhances the fish production. So in normal times, fishermen found ample amount of fishes. In contrast, in the western Pacific, as it is a site of downwelling, so nutrient supply in these coastal areas, that is the eastern part of Australia, Indonesia, Japan, uh, they have a poor nutrient supply in the coastal areas. So biological activity is poor in this part. So here you can see the picture. Uh, the hot, warm water that is blown further west by the trade winds and reach the western margin of the Pacific Ocean. Now, in the Pacific Ocean, when that warm water is not able to cross the Pacific Ocean, it is distributed in the subtropical areas of the Pacific Ocean along the eastern coast of Australia, Indonesia, Papua New Guinea, Japan, uh, East China Sea. All these coasts are facing or getting a warm surface ocean water. So atmospheric circulation occurs in the form of this, that is a lot of evaporation takes place from this warm water that goes up, lots of precipitation occurs, becomes cold and dry, moves as upper um, dry air towards the eastern Pacific, and comes to the surfacial condition in the eastern Pacific, forms the high pressure zone. So this is the movement of atmosphere. Now if we look at the movement of sea water with this uh, atmospheric movement, you can see that in the Eastern Pacific there the warm water is being taken away to the western margin by the trade winds. So relatively cold conditions exist in the eastern margin. The western margin of the Pacific Sea there forms the uh, site of convergence of one water, so downwelling occurs. Here you can see the warm water zone is much thicker compared to the western Pacific, and you can see the picnoc line, that is the zone demarcating the superficial warm water and the bottom cold water, that is in far depth in the western margin compared to eastern margin. In eastern margin of the Pacific Ocean, the thermocline is much shallower. So the sea surface condition or sea water condition in the eastern Pacific is much soothing, and as this is a site of upwelling, so lot of nutrient supply and lot of biological activity is found. Now this entire phenomena, the oceanic and atmospheric conditions in the equatorial Pacific Oceans, is the normal condition, and it is first documented by a British meteorologist named as Gilbert Walker, and according to his name the circulation is known as Walker circulation. So this will be the, or this should be the normal situation found in the equatorial region of Pacific Ocean. But uh, here you can see the sea surface temperature in Walker circulation or normal condition. The Eastern Pacific along the equators, there lies more or less the cold or uh, soothing sea temperature, whereas as we move from east to west along the equatorial Pacific, we found more and more surface warm water, and there is a crowding of warm water in the western Pacific. So all these islands, they are basically evidencing a warm humid climate with lots of rainfall. Now El Nino is the warmer phase of this Enso. So during El Nino, the eastern Pacific water, the fishermen evidence that the eastern Pacific water becomes exceptionally warm, that is deviating the normal Walker circulation model. Now you can also see that the difference in occurrence of thermocline. You can see in the Walker circulation the thermocline has a gently dipping, that is it is dipping from eastern Pacific towards western Pacific, so it dips towards west. In the western Pacific the thermocline is in far depth, whereas in the eastern Pacific thermoclines are much shallower. But during El Nino phase the thermoclines become more or less flattened, so almost equals amount of depth of occurrence of thermocline is found in both eastern and western Pacific. Now, why this flattening of thermocline occurs? That means why the Eastern Pacific surface water becomes warm. Now, this happens in years when the Eastern Pacific, the high pressure zone, the effect of atmospheric pressure becomes lower. That means the high pressure system in the Eastern Pacific becomes very negligible. Now, as the high pressure system in this Eastern Pacific becomes negligible, so with simultaneous effect, the trade winds, which is generally moving from east to west along the equatorial region, that also weakens. Now, due to the weakening of these two, the pressure system, the high pressure in the Eastern Pacific, as well as the trade winds in the uh, equatorial region, the warm surface water of the Pacific Ocean that is not taken to the western margin. So all the equatorial Pacific warm water almost remain at its places. In continuation, as the trade winds are weakens, so the superficial movement of ocean water from east to west also weakens. Now, what happens in the water circulation, that there occurs a mound, or there occurs a converging side in the Western Pacific and a diverging in the Eastern Pacific. Now, due to the weakening of the eastward flow of the surface ocean current, now the reverse flow, that is the equatorial counter current, takes into place. So as this current is not occurring properly, or this current, the equatorial current is weak, so now the equatorial counter current act more actively. So now the warm water of the Western Pacific that is distributed all through the equatorial region and also in the Eastern Pacific, that is the western coastal areas of American landmass, both North America and South America. So that is why peoples of Peru, Ecuador, they evidence a uh, much warmer surface ocean water. So now, due to this uh, exceptional warm water in the Eastern Pacific, so now lot of evaporation will take place in the Eastern Pacific. So from that evaporation, when it goes, the vapor goes up, it forms clouds. So lots of rainfall is now found to occur in the eastern margin of the Pacific Ocean, that is along the western coast of North and South America. So during water circulation, the regions or the continental areas which was generally dry, that region becomes much wet, much humid. And as the entire Pacific Ocean, you can see the warm water is distributed in throughout the entire Pacific Ocean. So often it is found that instead of a large circular sail occurring in the Pacific Ocean from west to east, there occurs numerous smaller sails. That means this large sail is divided into these some smaller sails. So now in the eastern part, as lot of vaporization occurs, so there forms a low pressure zone in the atmosphere. And oppositely, in the Western Pacific, there forms the high pressure zone. So you can see the atmospheric circulation also just reverse compared to the Walker circulation model. Now you can see the sea surface temperature from top, as the reverse winds, that is the trade winds, becomes weak, reverse winds are taking place, equatorial counter current is acting more pronounced way. So a opposite flow and gathering or converging of warm water found in the Eastern Pacific. So warm humid condition is found all along the coast of these subtropical South and North America, which is generally dry, but due to the El Nino condition, now it is evidencing a warm humid condition, and lots of rainfall is occurring there. So you can see sea surface temperature is also changed. Now, depending on the sea surface temperature, the atmospheric circulation, the rainfall also varies globally. In El Nino time, you can see all the Eastern Pacific and the Middle Pacific regions evidencing lots of rainfall. So the coastal areas or the west coast of equatorial to tropical America, they evidencing a lots of rainfall. The climate becomes wet. In contrast, during water circulation, the western margin of the Pacific Ocean, that is the eastern coast of Australia, Papua New Guinea, Indonesia, Japan, this South China, and all these islands, they was previously in a humid condition evidencing lots of rainfall. But during El Nino, they are now facing a much dry condition. And look at the conditions of other areas. The eastern coasts of America along the equatorial to tropical regions, particularly the South America, that is dry. If you look at India, the most of the places of India remains dry during the El Nino phase. Now, what the first signs of El Nino? What are the signs that El Nino is taking place? The trade winds in the southern Pacific weakened or headed east, that is oppositely flowing. Rise in air pressure in the Indian Ocean, Indonesia, as well as Australia. That means in the western margin of the Pacific Ocean. A fall or drop in air pressure over Tahiti and rest of the central and eastern Pacific Oceans. The Tahiti, Galapagos, all these islands and the eastern margin of the Pacific Ocean, they evidencing a low pressure zone. Warm air rises in Peru and all the coastal areas, western coast areas of America. Warm water spreads from the West Pacific and the Indian Ocean to the East Pacific. It takes the rain with it, causing rainfall in normally dry areas and drought in normally wet areas. So what found in the Walker condition time, that get reversed during El Nino. So there is flood, lots of flood is found in those places which are normally dry. Oppositely, those places which receive lots of rainfall, they becomes exceptionally dry. The effects of El Nino: wet winters over the southeastern United States. In the eastern part of the eastern margin of the American landmass, the winter is wet. El Nino events often result in unusual and destructive weather patterns. The normally arid climate of the tropical South American coast may experience floods and landslide because of lots of rainfall. Warmer weather in the upper states like Canada, um, drought, that is dry condition in Indonesia, eastern part of Australia and other places that are typically wet during water circulation during normal conditions. Due to these dry conditions, a lot of wildfires, mudslides are found to occur. El Nino events prevent the process of upwelling, the movement of cold, nutrient-rich water to the surface in the western coasts of Peru, Ecuador, and Chile, and this can have a devastating impact on marine life because the marine life does not get the fresh nutrient, and it often affect the local economies because the fishermen does not get the marine life which is supplied to the market for regular use. So the local economy, uh, which is related with the fishing activity, that can be hardly affected by this El Nino effect. Apart from that, one very sensitive organism found in oceans, particularly in the western coasts of America, that is coral. Now, due to the occurrence of El Nino, that is concentration of more warm water in the western coasts of America, the corals are also affected because most of the corals, they are very much sensitive to temperature. They are mostly uh, a suitable temperature condition is about 20 degrees centigrade. So more warm water concentration affects their growth, and sometimes they are hard hit, sometimes they fade dead. So corals are also affected. Not only corals, but all other organisms are also affected. The opposite phase or the opposite condition of El Nino is the La Nina. Generally, La Nina occurs in the following year of El Nino. So, what occurs in the La Nina? If we look again in the form norm in the starting from the normal Walker circulation model, then Walker circulation model, there is warm water converging in the Western Pacific, and Western Pacific becomes a low pressure zone, lots of evaporation occurs, lots of cloud formation, rainfall, and the Eastern Pacific is becomes the high pressure zone, becomes dry, relatively cold. The thermocline is inclined from east to west. So this is the Walker circulation model. La Nina is basically an accentuated version of Walker circulation. So during La Nina phase, the circulation of ocean water or the movement, the activity of trade wind becomes much stronger than the normal Walker circulation time. So what happens during La Nina? Due to much stronger trade winds, which is blowing from east to west, now the warm water was blown further west and often encroaching the eastern part of the Indian Ocean. So now, due to the far pushing of warm ocean water, due to more strong activity of trade winds, um, more and more gathering of warm water into the Western Pacific, all those areas. So more enhanced low pressure zone exists, more enhanced evaporation occurs, cloud formation, and more rainfall occurs. But the these areas, that is the western margin of the Pacific Ocean, that is the eastern part of the Australia, um, Papua New Guinea, Japan, they are evidencing these kinds of warm condition, heavy rainfall during the Walker circulation model. So La Nina, these things, these atmospheric things, the climatic these things, and the ocean water, the condition is slightly more enhanced, but remarkably changed found to occur in the Eastern Pacific due to the more strong trade winds. The warm surface ocean water of the Eastern Pacific is completely taken away to the Western Pacific. So now the cold deep water is reaching directly or abating directly into the surface ocean. You can see the thermocline is directly abates, directly cross cuts the ocean surface. What was previously during the Walker circulation time, that thermocline is close to the ocean surface, but during La Nina phase, thermocline abates against the ocean surface. That means directly the cold ocean water reaching to the surface. And more depth is found in the Western Pacific. That more and more depth of occurrence of thermocline found in the Western Pacific. So the inclination of thermocline becomes slightly steeper during the La Nina phase. So you can see the surface ocean temperature by these colored portions. The cold deep ocean current is now directly reaching at the surface in the Eastern Pacific and all the coastal areas of the South America, whereas warm condition exist in all these islanding land masses and the eastern part of Australia. Now, if you look at the rainfall, the eastern margin of Pacific Ocean, that is the western coast of America, that becomes cold but exceptionally dry. The entire Pacific Ocean almost remains dry because the thermocline is now reaching the surface ocean water. Thermocline is cross-cutting the ocean surface, and you can see what was previously in the water circulation, that only the eastern part of the Australia is evidencing high rainfall now during La Nina phase, as it is an enhanced version or accentuated version of water circulation. So almost the entire Australian continent evidencing warm and humid climate, and along with that lots of rainfall. So all these islandic land masses, Indonesia, Japan, Papua New Guinea, and all the land masses, they evidencing a heavy rainfall. Now, along with this, you can see other areas climatic conditions also changed. If you look at the rainfall in India, what was previously dry during El Nino times, now during La Nina, it becomes much wetter, much humid. So all the global climatic conditions are changed with these El Nino and La Nina, because the circulation is now reaching more in the Indian Oceans, and simultaneously all the circulation in the other oceans, they are affected along these equatorial to subtropical regions. The effects of La Nina: rain clouds form as a result of uplift of warm and moist air in the Western Pacific. Monsoon seasons will be more intense in a La Nina year. Western equatorial portions of South America may be in drought condition, that is the coastal areas of Peru, Ecuador, they found extremely dry condition. In the United States, Washington, Oregon may see increased precipitation that occurs in the eastern part of the South America continent. So they found increased precipitation. Portions of California, Nevada, Colorado may see drier conditions. These are the occurs in the western part of America. La Nina events often bring wetter than normal weather conditions. Much of the land masses of Indonesia, Northern Australia, Malaysia, Japan, all these continental land masses. So here you can compare the sea surface temperature during El Nino and La Nina. El Nino, much of the gathering or much of the convergence of surface ocean warm water in the Eastern Pacific, and in La Nina, the Eastern Pacific is relatively cold because the thermocline is now directly reaching to the ocean surface, and you can see along the equators almost the entire Pacific Ocean is now evidencing and cold surface ocean water. So that's a brief idea about El Nino and La Nina. Hope it will help you to understand the ocean circulation or ocean current processes. Thank you.